Okay, so returning back to Clojure. Working with nested data structures. For the purpose of this exercise, imagine that you are working with a little shop called Sparkling, whose business is to trade gemstones. It turns out that the owner of the shop knows a bit of Clojure and has been using a Clojure REPL to manage the inventory with some kind of homemade database. However, the owner has been struggling to work with nested data structures, and they require help from a professional, you. The shop won't share their database because it contains sensitive data. They have just given you a sample data set so that you know about the shape of the data. The shop owner read a blog post on the internet saying that the pure functions are amazing and make for a good quality code. So they asked you to develop some pure functions that take their gemstone database as the first parameter of each function. The owner said you would only get paid if you provide pure functions. In this exercise, we will develop a few functions that will help us understand and operate on nested data structures. A pure function is a function where the return value is only determined by its input values. A pure function does not have any side effects, which means that it does not mutate a program state nor generate any kind of I/O. Open up a REPL and create the following hash map representing the sample gemstone database. Okay, we're about to be in business. I thought I just launched this. All right, so let me run this REPL. So they have defined gemstone database, and it's a map, and we know that it's a map because we see the braces with keys on it. All right, so and everything's within parentheses. Remember, the difference between def and let is always has a vector for defining key value pairs, and def doesn't, I guess. So we call it take two. So we call it def. I don't know what it's called, gemstone database, and it's supposed to look like this with some key. I think this goes like this with some key and some value like that, maybe. On here they have gemstone-db, gemstone-gb. Okay, got that right. And then they have Ruby, which has name, stock, and sales. So this is called Ruby. What was this right? Hold up. Name is Ruby, stock, and then sales. No, it's the name. It's nested. So this is within here, it's going to have a key called Ruby, and then it's going to have name. Okay. And that is lowercase. So you have Ruby, and then it looks like it has another set of braces in which that's going to be name, and then you would have was it stock, and then you have sales, something like that. And so we say name is going to be Ruby, stock is going to be 480, then sales is going to be, it's probably a vector, right? Yeah. 1990, 3644. I wish I could copy all this. 1990, 3644, or something like that. 6376, 4918, 376, 4918, 7882, 6747, 7882, 6747, 7495, 8573, 7495, 8593, something like that. 85 is 8573, and then 5097. 5097 and 1712. Okay. So, and then there's a properties on here. Okay. So then there's properties, which will have dispersion, hardness, refractive index. Dispersion. This is supposed to be a key, right? So that's going to be 0.018, 0.018. What is this? Zero 0.018 is dispersion. Hardness is 9.0. Oh, great. Do this one more time. 0.018. Then hardness is 9.0. And refractive index. Refractive index is 1.77, 1.78. 1.78. Color red. Okay. Color red. Now is that a capital red? Yeah. Okay. Now if I do Shift Alt L, didn't like that. I didn't like that at all. Why didn't you like that? Unable to resolve stock in this context. Oh, yeah. Because it's supposed to be a key. Right? Shift Alt L, everybody's happy. All right. Shift Alt L, everybody's happy. All right. Okay. Hey, the only two observers watching me read a book. So we have that. And so then they say one of the most popular questions the shop gets from its customers is about the durability of a gem. This can be found in the properties of a gem at the hardness key, okay, which is this right here. The first function that we need to develop is durability, which retrieves the hardness of a given gem. Let's start by using a function we already know, get, with the Ruby gem as an example. So they have get, and then gemstone, database, Ruby, properties, hardness. It works, but nesting get is not very elegant. We could use the map where keywords as functions and see how it improves the readability. Yeah, I'm not going to write this. Use the keywords as a function to see how it improves the readability of our code. So hardness, properties, Ruby. Just it says this is slightly better, but it's still a lot of nested calls and in parentheses. Surely there must be a better way. Okay. When you need to fetch data in a deeply nested map such as this one, use the get in function. It takes a vector of keys as parameters and digs in the map with just one function call. So use the get in function with the Ruby properties hardness vector of parameters to retrieve the deeply nested hardness key. Okay, so if we look at this, Ruby properties hardness. Oh, that's cool. All right, so they're saying do this. They're saying in parentheses, say get in, and then I think they're saying no, get in, and then they say gemstone db, and then within, I'm doing this right, they're passing in a vector as the argument. They're passing in the vector as the second argument, Ruby properties hardness. So they're saying keys Ruby, keys Ruby, uh, properties, however you spell properties, and then hardness. Okay. They're saying do that. So go ahead and load that in there, and then Shift Alt P. That's not what I was looking for. That's not what I was looking for. Ruby properties hardness. Ruby properties hardness. Ruby properties hardness. Why didn't this return what I thought it was going to return? This should have been it right here. Boom. Boom. Let's get in. Uh-oh. I don't, that right there. That should have worked. Hold up. Get in. Gemstone DB. That should have worked. Now I got to figure out why that didn't work. Hold up. First, that, and then why am I getting this? Hold up. Why, what am I doing wrong? We have within parentheses get in. We have gemstone DB, and then we have the keys in here: Ruby properties hardness within the vector, and then we close the parenthesis. So this line is fine. Like this is fine. Something has to be wrong with the structure that I have up here, which that looks fine to me as well. So what did I do wrong with? Unless you guys see it, try with less parentheses or try with less properties. Did you send gemstone in the REPL? Ruby and properties are set at same level in the DB. Oh, is it? You said Ruby and properties are set at the same level. Hold on, let me go back. Oh, okay. Thank you. That would have took me a while to figure out. Load that in. Yay! All right, good stuff. Appreciate that. Okay, thank you. Uh, I assume that you're a Clojurist or something. You you write Clojure. All right, so it works with nesting. So then they said this. This is no. I did that part. Hold up, go back. I like this syntax, man. This is cool. All right, so we did this. Great. The vector of keys reads left to right, and there is no nested expression. It will make our function a lot more readable. So if I marinate on this for a bit, to me, this translates to like this is an alternative to like dot notation. So for example, you would have like you would have gemstone DB dot Ruby dot properties dot hardness, and that would give you the value if you were doing your typical like Java or C# notation. But in Clojure, their alternative is you explicitly call a getIn function that's in your Clojure.core library. You pass in the map that you want to operate on for getting in for retrieving a nested value uh, within a data structure that's hence nested, and then you provide that path Ruby properties hardness. So instead of Ruby properties hardness, you pass in Ruby key properties key hardness key, because hardness is part of properties. properties as part of Ruby. All right, so if I say that to myself, that kind of like sinks in a little bit better. And you say, yep, you write Clojure, and then is also possible. So you said, you're using this forward arrow. So you're saying forward arrow and then gemstone database. How is that? You're saying I could just do this? That's not possible on unless the syntax I'm writing is wrong. Oh no, you're not using the vector. But, well, before I do that, let me just put that on a separate line. But first, let's make sure this thing still works. It does. All right. And so now you're saying that there's an alternative to that, in which you replace get in with an arrow, and then you're just without the brackets doing this. Wow. Okay. So apparently this arrow thing is a macro. But they use that for a couple of things. So it says threads the expression through the forms, inserts X as the second item in the first form, making a list of it. I don't see anything about this saying that it's an alias, that this arrow is an alias. How did it know? How does this arrow know that it's an alias to the function get in? Because, like, how does it know that? It doesn't say it in the documentation. Control D to duplicate a line. Okay. Yeah, I'm gonna try to force my brain to forget this one because I don't understand how it knows. Say Control D to duplicate a line. So instead of doing Control or copy or Control C and then Control V, you just do Control D. Is that just within IntelliJ, or is that just a rule in general for any editor like Visual Studio? Let's see. Holy crap! Oh, that's in Visual Studio too. Whoa! Hey you! Hey you! Give me that. Um. Okay. So that's cool. What else? So we got through that. Thank you for assisting me with that error dealing with nesting and it not really being in the right format. So where am I at now? The vector of keys reads left to right, and there is no necessary. All right, create the durability function that takes the database and the gem keyword as a parameter and returns the value of hardness. I thought that's what we just did. Yeah, I think didn't we just do this? No, we did get in. Hold up. Something's not right. They're saying do this right here. Oh, they're saying define a function called durability. Yeah, I'm sorry. I got thrown off. All right. So I could do that. So can I just do this right here? Can I just say define function durability, however you spell durability, and then that durability, how does that work? I'll probably like paste this in here, right? As a reference. And durability is going to take gemstone database. No. It takes a, okay, so with let declarations, we use a vector for arguments. And when we say defined function, we also use a vector for arguments based on key value pair. Okay. So define durability, and then you say DB gemstone. So database. No, these are two different values that we're passing in. Okay, I got it now. It takes me a while. I'm sorry. So you say DB, and then you say gemstone, and so then we would want to replace that gemstone DB with this, and then gemstone is this right here, right? I would think that's how it would look. Is that how they did it? Get in DB gemstone, okay, and then you test it with durability gemstone DB Ruby. So let's try that. We say, hold up, take two. Yeah. All right. So then we call durability, and then we say gemstone. Why did I do that? Gemstone, and then we say no, that's not right. I just say Ruby. I pass in the key Ruby like that, right? Yeah. All right. So theoretically, I define this. Oh, hold up. Crap. What did I just do? Hold up. How do I get back? Okay. So theoretically, I should be able to load all that in, and then it says it's a compiler, gemstone, and this. Is that better? Okay, it says it's loaded, and then nil. Because this one right here. All right, take two. Fuck, really? Give me a second. Failed vector at, give me a line number, 218. What is wrong with this? If we, okay, let me check my stream to see. Nope. Okay. It says syntax error. It says gemstone is an issue. Get in database, gemstone. Ugh. Properties, hardness. Oh, because I'm supposed to. Something's not right. Durability. It's supposed to be gemstone DB. That's why. Hold up. That's what it's supposed to be. Thank you. Fuck, that took me forever. Okay. Durability, gemstone DB, ruby. And then you can say durability, gemstone DB. I don't know what this Moisati grade. I don't remember putting in. I'm not going to do this line. Apparently, a ruby is not simply red, but near colorless through paint through all shades of red to a deep crimson. Who would have thought? The owner is now asking you to create a function to update the color of a gem because they might want to change some other colors too for marketing purposes. The function needs to return the updated database. Let's try to write the code to change the color property of a gem. We can try to use a source. So source, ruby, gemstone DB, and then properties. It seems to work, but all the other properties are gone. We replaced the existing hash map at the key property with a new hash map that contains only one entry, the color. We could use a trick. Do you remember the into function? It takes a collection and puts its values into another collection like this. Into A1, B2, and they put C3. If we use the update function combined with into, we could obtain the desired result. Try to use update combined with into to change the color property of the ruby. So they have update and then they have ruby, gemstone DB. So update and then the ruby key of gemstone DB, and then properties into color, near colorless paint, boom, 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 boom. So then they're saying if you use that, that's great, but there are two problems with this approach. First, a combination of update and into is not very readable or easy to understand. Second, we wanted to return the entire database, but we just returned the Ruby entry. We would have to add another operation to update the entry in the main database. Perhaps by nesting another into reducing readability even further. Okay. As with get in, Clojure offers a simpler way of dealing with nested maps, assoc and update in. They work like assoc and update, but take a vector of keys, such as get in, as a parameter instead of a single key. You would use update in when you want to update a deeply nested value with a function. For example, to compute the new value with the previous value, Here we simply want to replace the color with an entirely new value, so we should use associate. Use associate to change the color property of the root. Hold on, what's the difference between associate and the update in? You will use update in when you want to update a deeply nested value within a function. For example, to compute the new value with the previous value. Here we simply want to replace the color with an entirely new value. It sounds like they're saying the same thing. You would want to use update in when you want to update a deeply nested value with a function. Here we simply want to replace the color with an entirely new value, so we should use associate. So update in seems like it's focused on a function, and so associate isn't as functionally. So use associate to change the color property of a Ruby gem. Associate gemstone DB, Ruby properties color, near colorless through pink through all shades of red to a deep crimson. All right, I could try that. Associate gemstone DB. Ruby properties color, Ruby properties color. Then the second argument, near colorless through pink, near colorless through pink through all shades. Near colorless through pink through all shades of red to a deep crimson. Of red to a deep crimson. I like how this editor has spell check. I don't know how to spell crimson. How do you spell crimson? There's no P in crimson. So associate gemstone Ruby properties color, and we're changing it. So for that, I think you said use Control D. It was color, and this would provide red, but now we're saying now we're going to change that to this. Okay. Okay. So get in associated. Notice how gemstone DB was returned entirely. Can you notice the value that has changed? There is a lot of data, so it is not very obvious. You can use the pprint function to pretty print the value. Use pprint on the last return value to improve the readability and make sure that our associated expression behaved as expected. In REPL, the last return value can be obtained with *1. Preprint *1. Shoot, hold up. Take 2. Preprint *1. Shift Alt P. Okay. We will not use preprinting everywhere. It takes a lot of extra space, but you should use it. Create the change color pure function, which takes 3 parameters: a database, a gemstone, keyword, and a new color. This function updates the color in a given database and returns the new value of the database. Okay. So we're going to say define function change color, and then within a vector we're going to have a, what are they saying? Database, gemstone, and new color. Database, gemstone, new color. New color, because they probably have it like that. Then they paste this in here. It should already be done, right? So then associate in DB the gemstone, this right here. And then we put in, should be this right here. Okay. See how that works out. So I could, theoretically, I should be able to say, change color, gemstone DB, and then I should be able to say, I don't know if this is, it should be blue. It's missing the actual gemstone. Is it like that? That's it. And then I'd say pprint *1. Okay. Okay. So get in, assoc in, update in. All right. So your newly created function behaves as expected. The owner would like to add one last function to the record, the sale of a gem, and update the inventory accordingly. When the sale occurs, the shop owner would like to call the sale function with the following arguments: a database, a gemstone, keyword, and a client ID. Client ID will be inserted in the sales vector, and the stock value for that gem will be decreased by 1. As with other functions, the new value of the database will be returned so that the client can handle the update themselves. We can use the update in function in combination with dec to decrement, decrease by 1 the stock. Let's try it. Update in gemstone, diamond, stock, dec. Output is not very readable, and it's hard to verify that the value was correctly updated. Another useful command to improve readability in the REPL is the print level option, which can limit the depth of the data structure to terminal. Use the print level option to set the depth level to 2 and observe how the result is printed. Set. Updated in gemstone DB, diamond stock, dec. We can use the updating function again, this time in a combination with conjoin and a client ID to add the sales vector. Let's try an example with the diamond gem. Updated in gemstone DB, diamond sales, conjoin 99. Set print level to 0 to reset the option and reevaluate. Now contains the value 99. So update in. Update in just takes a function. All right, so I'm just going to take a break. I'm tired. My brain hurts. See ya. Bye.